Hi friends! Today here in the lab we have a handheld Kenwood TH-48 and well, it came in with no audio, and you may know that that could be an easy mechanical issue, so maybe the audio jack, but on the other hand it could be a serious issue as well. So let's see what we have, and let's see what we can do for our nice handheld. Okay, and here it is. So what we can see or say so far is that we can really switch it on. So you see that it is coming up, it's firing up. But yeah, other than that, so squelch is completely counterclockwise and our volume is really fully clockwise, so there is really no life here on the audio side, and touching here monitor should give us a static at least, but nothing. Our lamp is working, so that all is fine, and we can operate here the frequencies. By the way, that TH-48 is the UHF variant, so there is as well a TH-28, I believe, and that is a VHF unit, so the UHF unit is a bit more seldom. But anyways, it should be mechanically more or less the same. So I hope I can use the TH-48 service manual, as I do not have the 48 one. So, okay, anyways, let's see what we can do. Okay, and so first what we can always do is simply plugging here an external speaker to our radio, and then we can do exactly the same. So we start it, of course, and let's see. No, nothing at all. So that is not the issue. Nope. That is not our problem. So that would have been much too easy, most likely. No, nothing. Absolutely nothing. Okay, that means we really have to take it apart, and we really need to search for our audio signal. Let's see. So we have to crack it open, and of course that means it is always fun with handheld radios. So that is our battery, and now we have here some screws. Yeah, let's see how I can get it apart. And then our next step. Okay, so our radio is cracked open, and now we need to find our way here through our PCBs. Yeah, basically we have three boards. So first is our control board with display, and here our push buttons and what have we. Then we have our IF unit and our RF unit. So the IF unit, I believe it is here the upper one, and then there is a second layer down below, so you may see it here a little bit where the BNC connector is connected to, so that is the RF board. and underneath here this shielding, we probably have our amplifier, our HF amplifier. So, well, let's try to identify where we have what, and then we can start with our first testings. I have connected here my handheld to the communication tester, and what we can see so far is that we have here S meter, so that is telling us that there is really something received here in the radio, but nothing gets here to our speaker, and there is no signal either here on our ribbon cable, which should carry our audio signal coming from, well, it should come directly from the HF board or RF board, however you want to call it, and it is going through our audio jack. So that is what we already tested, if it is only a mechanical issue here, but it is not really nothing, so it must be something right from our audio IC, or maybe earlier. So next step is we need to get out here obviously our IF board to get access finally to our audio amplifier, that we can directly test at our audio amplifier, and the audio IC must be here underneath, so on the IF board but on the other side. So I try to lift here our IF board to get access. Yeah, and saying that, you see I have here lifted the IF board, and we have all the ICs we need here, and so yeah, as I told you, it is always fun to find here the way through our circuit, but what I can tell you is that this here is our audio IC, right? And I've tested our audio IC on the output with the scope, and I can tell you there is no output. So that means if there is no output, there can't be anything at our speaker, so that is for sure. Then I have tested here the power supply, and we find that finally here our power audio IC is not supplied with power, and that is now what we need to look for, and therefore let's have a short a quick look into our schematic, that we understand what we do. Okay, and here is our schematic, and here we have our audio IC. So let me zoom it in a little bit more, that it is easier to see. So as I already told you, I have tested here our output, and there is no audio, and there is no audio at the input either, so something is wrong. Then I tested here for our voltage, our supply voltage, and I found that we do not have any voltage to our audio power amplifier, right? At Q13 we have at our emitter we have our plus B, but at the collector there is no plus B. So we have here a so-called arrow amp, right? And you know, the arrow amp needs to deliver voltage to our Q13 so that it can switch through. And what I can say so far is that we do not get here a triggering voltage for our Q14 because, and that is what we have for the moment in time, so our Q15 does not get its oh, can you see it? I hope yes. So our Q15, which is a digital transistor, does not get its 5C. So that is a 5-volt supply voltage, and we have it here at our emitter, and normally we should then have approximately 5 volt here at the base, which is not present. So I know that our 5C is available at its supplying transistor. And when we go over here to our Q1, you see that finally we have our plus B, which is present at Q1, and the switching network here is obviously working right, so that we have our 5C, that means 5 volt at our collector, right? And therefore I know that Q1 is working, so no problem whatsoever, but for a reason I don't know yet, we do not get our 5C here to our digital transistor. So that is a problem so far. But if I supply from an external power supply 5 volt here to our base, which should of course do our Q15, okay? So our Q15 should deliver our approximately 5 volt here to the base, and then normally our Q13, which you can't see right now, this guy should switch through and should finally engage our power amplifier, okay? So if I put really 5 volt from an external power supply to our C4T, so that is an electrolytic capacitor, right, which is filtering here our incoming voltage just a little bit, and maybe that you know, it is only filtering, I believe. So therefore I can put 5 volt here to the C4T, and then I have seen that it is working. Okay, when we zoom in, okay, when we zoom in here, and you see how small it is here really, so that is really no fun, right? We have here our Q14, that here is our Q14, and this electrolytic SMD capacitor is our C40, right, where we should have our 5 volt. And I have here my power supply, which is delivering 5 volt. I mean, that is simulating our battery, okay, and you see that the unit is switched on. It is pulling 65 milliamps in receive, right? And our 5 volt will be our simulated 5 volt, which should come over our 5C. Back to our PCB and back to our, and I really need to be very careful here that I do not short here something. Anyways, here, where is it? Here I have now my 5 volt, and I hope I don't do something silly here. So if I put it here to my electrolytic capacitor, you can hear it, I believe. We have audio. And I reposition now my camera that you can see it on the tester. And again, so let me supply my external voltage here. I should take the right probe for doing it. And here we are. And you see, it is 1 kilohertz. It is a clear sign. We have 33.9 dB synod. So far it is working just fine, okay? So the only question for now is, why does 5C not getting here to our Q15, so that our Q15 is obviously not able to supply our Q14. So is there an interruption on a layer here on the PCB, or what has happened? So that is of course now the next step. We need to see if there is maybe an interruption from our Q1, which is delivering our 5C, so we have seen it before. So we need to see if there is maybe an interruption in here our supply line, that the 5C can't get here to our emitter of Q15. Okay, and as discussed, I have tested the connection between here our little digital transistor, which is this little guy here, okay, on the right hand side we have the emitter, right, and the emitter should be connected here to Q1, so that is Q1, okay, and from a collector Q1 to our emitter digital transistor we should have a connection, right? So, but I really do not have a continuity, so there is definitely an interruption. So that means obviously something went wrong on our PCB. I don't know what, but what happens if I try to bring this both lines together? And believe me, that is no fun here through the camera. Really no fun. Must be here. Yeah, I do have problems to get a good connection here, because I'm working around the camera, which is a pain. That is a pain, believe me. But it seems that I'm able to establish a connection between. Let me do it a little bit different. I simply solder a connection in, and then let's see if that works. Okay, so here's our little board where we have to work on, as we know that there is interruption. Well, but additional to that, since we really do not know what has happened here on the board, I mean, why finally do we have this interruption? No idea. But what I can say so far, I mean, here that is our digital transistor, and when you look around, it all looks a little bit dodgy, so I don't know. So I think it is really the best to take it out, and I've already taken out here the little capacitor which has been down here, and I think I take here the digital transistor out just in case, because yeah, you have seen that it looks like that it didn't switch through. Maybe that we have a problem with the little digital transistor as well. So therefore I think it is not wrong to simply swap it out to simply reduce the risk that something is going wrong here. Okay, so I have taken off the transistor down here, so you can see it, and I've cleaned it once with alcohol, and here we see a through, and I wonder if what we can see here, the black whatever it is it corrosion? I mean, I don't know. It all looks a little bit odd, and well, I'm still wondering why we lost this connection. I mean, it is not really high power what is going through this traces, so you know, it is still a little bit funny. Well, anyways, let me clean it entirely, and then let's replace here a new digital transistor, and of course here a new little capacitor, right? Yeah, as you can see, we have replaced here our digital, where is it here, our digital transistor, and we have replaced here the capacitor, and you see we have here our bridge from our supply transistor to our digital transistor. Unfortunately, I did not have exactly the right size, so originally we have here an SOT for 16 package, and I only had SOT 323 package, so that is a little bit bigger, but yeah, finally no problem. It is in. You can see that it is a little bit bigger, but that is no big deal. As long we are able to get it in, no problem. So that's it, and yeah, now I'm really curious if this configuration will work, or if we maybe have an additional issue here around. Okay, so our board is back in, and yeah, you have seen that we did the repair on the other side. But still, the question is, why do we have this interruption, and why does it all look so corrosive, right? So therefore I did another deep inspection here on the board, and yeah, what can I say? And again, it is all about leaking electrolytic capacitors. So look here, and look here on, yeah, come on, look here. So what you can see there, I hope it is really visible here. And this through, what you see down here, and you see that I'm here going over it, and you see that is a through where we found that it looked like a little bit funny, and that is exactly the through over our digital transistor we replaced, where we already wondered why is there corrosive material on the PCB, and that is the reason why. Here our electrolytic capacitor is leaking once again, and you can see it here at this contact here of the other electrolytic capacitor. So minimum this both electrolytic, so this one here, right, and of course this one here are leaking, and that is the reason why we have the interruption on, you know, our power supply line. And it is really always the same. This electrolytic capacitors, this SMD types are really critical, and you see it once again. So what do we have to do? Very easy. We have to take off all these electrolytic capacitors, and we have to replace all of them until we really can finally go ahead and see if our repair was successful. It does not make any sense to, you know, try to take it into operation with this electrolytic capacitors, because these capacitors can create additional problems, and we simply do not want it. Yeah, and we can really see the degree of damage. So this area is where we have our digital transistor underneath, and you see that we have signs of corrosion everywhere, and the same is here under this, which was the second one where we already have seen the corrosion with the built-in capacitor. So yeah, that means I hope it was not already too late, but yeah, since we know that you know, this acid went through here our through holes, and was already able to damage yeah, a trace. Whew, it is really hard to say if we really can rescue this radio for a long time, you know. And you see here also acid went here under the solder stop, and you really can see it everywhere. Okay, so let me clean up here our board, and maybe that then we are able to see a bit more. And even after cleaning, you see that we still have here a lot of yeah, residue from the leaking capacitors, and it is really deep here in the throughs. So that is what we clearly see, and here as well, and here our solder stop mask just went off. So I guess I should try to clean it a little bit more to get as much as possible away from the acid, because otherwise nobody can guarantee that in the future there will not be another damage of through or whatever. So I try my best to clean it, and of course I have a special spray to spray it out, but still we can't guarantee. I try to get the solder mask off where I have seen that there is acid under the solder mask, and well, the only thing is that we were able to ban the process which was already going on here, and I hope that the spray is able to neutralize a little bit the acid, so that the process is more or less stopped. Next step will be that we put new electrolytic capacitors to the board, and then we will see if it works or not. So our new capacitors are in, and yeah, I just wanted to put everywhere here our titanium electrolytic capacitors, but that was not possible due to the fact that there is too much solder mask gone, and you see how wide these titaniums are, and that would have meant that you know, the contacts are over the ground, and yeah, you know, that is something with, you know, the open copper. So I thought that is not a good idea. So this one is not critical because, you know, here is no ground plane around. But here I would have come here over into the ground plane, and, you know, that could cause shorts, and I simply wanted to avoid it, and therefore I decided, after I've seen that it is not a good idea to put finally this SMD electrolytics back. I mean, not the old one, new one, but yeah, so it is. I mean, the best what we can do. Now I clean it just a little bit more, and I hope that we can do then first function test. Okay, so we have already prepared for testing, and yeah, our power supply is set to 7.2 volt. Like so, and now I connect here my plus wire, go back to my radio. Okay, everything should be fine. So let's see what will happening when I switch it on. Hey, here we are. Our static is back, our tone is back. Very nice. So, okay, let's switch it off. Okay, that is great, really great. So let me assemble here the radio a little bit, and then we can connect our communication tester to see if really everything is fine. Yeah, our radio tester is ready and everything is connected so far. And when I now switch on the radio, we should get receive. And wow, here it is. everything is absolutely fine. And let me check here. So that is annoying when I now pull here my connector. So we have the internal speaker back working, and of course here our radio is connected to the power supply as the battery is nearly discharged, and it is charging right now, so that is good. Radio is off, and you see over there that we have the radio charging, which is fine. So that is telling us that the charging circuit is working as well, right? And yeah, I can switch it in, and it fires up, and yeah, you see it is working really excellent. So that was a problem, and I can tell you, well, that was really an exciting fixing here. I mean, very often we have repairs which are kind of boring, but this was not. So that was pure fun. And yeah, so that means radio is working. We are really back at the end of the video. I hope you enjoyed it, and I stop it here. I have to finalize here, putting back the knobs and what have we. And I stop here. Thanks for watching, and catch you next time. Bye.